Welcome back to our channel. Today we are diving into the fascinating world of chemistry to explore the two types of catalyst, heterogeneous and homogeneous. Let's understand how they work and why they are crucial in chemical reactions. So in the last video we learned how catalyst affects the activation energy. That is, catalysts reduce the activation energy or lower the activation energy by providing an alternate pathway for the reaction to occur. Now, there is two types of catalyst present. The first is heterogeneous catalyst and the second one is a homogeneous catalyst. Let's understand how they work and why they're crucial in chemical reaction in the next slides. Let's look first at how homogeneous catalysts work. Homogeneous catalysts are catalysts which are in the same phase as the reactants, typically both in a liquid or gaseous state. The mechanism is slightly more complex. First, the catalyst interacts with the reactants to form an intermediate complex. This lowers the activation energy that is required to get the reaction started. In the reaction pathway, we see two transition stages, each with its own energy peak. After the first transition, the intermediate complex is formed, which is more stable and has lower energy. In the second transition, the intermediate breaks down, resulting in the final product and the regeneration of catalyst. Okay, now let's move on to heterogeneous catalysts. As shown in the slide, heterogeneous catalysts are in different phase than the reactants. For example, in many industrial reactions, the catalyst is solid while the reactants are in a liquid or gas state. So how does this catalyst work? Here's the process. First, the reactants attach or adsorb onto the surface of the catalyst. This proximity makes it easier for the reactant bonds to break and form new bonds. The reaction reaches a transition stage with lower activation energy than it would without the catalyst. Once the reaction completes, the products detach or deabsorbs from the catalyst surface, freeing it to catalyze another reaction. One major advantage of heterogeneous catalysts is that they can be reused many times. Commonly, these are metals or metal oxides, which are excellent at attracting reactant molecules. But unlike the heterogeneous catalysts, homogeneous catalysts are often faster and more precise, but they can be challenging to separate from the final products.